Alright, so solving trig functions part 1. Alright, technically I guess part 3 because we've been doing this for a while, but this is section 8.3 and this is where we're really going to get into it. So the first thing that you have to do is you have to look at this chart that I have. It will be up in just a moment. Okay, and where's my chart? Okay, so this chart is super important. I would recommend that you in some way, shape, or form write this down, take a picture of it, something like that. I will not expect you to memorize this. I will definitely give you a copy of this on this test, okay? So this tells us that how we can solve trig functions, all right? It gives us all the possible solutions, all right? So if I have a function, sine of x equals c, okay, and it gives me all the different possibilities of what c could be. C could be between -1 and 1. C could be equal to 1. C could be equal to -1. C could be greater than 1, or C could be less than -1. So this value is important, and it's going to tell us how to find the solution. So if it's between -1 and 1, we will take the inverse of sine and say plus 2k pi. And then we will subtract whatever the answer that is from pi plus 2k pi. So if it's between -1 and 1, there are two solutions, okay, that I will find. If it's 1 or -1, there's only one solution. It's pi over 2 or negative pi over 2 plus 2k pi plus 2k pi. 1 is positive pi over 2, and -1 is negative pi over 2. If it's greater than 1 or less than -1, there is no solution. Okay? Cosine also has these values. So if you notice for cosine, between -1 and 1, okay, it's the inverse of cosine c plus 2k pi, and then the negative inverse cosine of c. If it's 1, it's 0 plus 2k pi, which is just 2k pi. It's equal to -1, it's pi plus 2k pi. If it's greater than 1 or less than -1, there is no solution. Now, a tangent, which happens to be covered up by my little thingy over here. And now, now that came back up. All right. Tangent works for anything, so you can take the inverse of anything of tangent, and it's just simply the inverse tangent of that plus k pi. So this chart, please keep track of this chart so that you can have, so you can find your solutions. If you have this chart, it's very, very simple. There. All right, so here we go. We have a function, sine of x equals negative 0.682. Oh, by the way, these are radian modes. Please make sure you calculate in radian mode. Okay. So since it's between 0 and -1, I will simply take the inverse of this and add 2k pi, and then I will do pi minus my solution and add 2k pi. So let's look at how we do this. Okay. So I take the inverse of that, and I end up with x. So x is equal to negative 0.7505 plus 2k pi. And then I'm going to go pi minus that to get my other one, because that's what my chart says. Pi minus negative 0.7505 plus 2k pi going to equal 3.8921 plus 2k pi. And that is my solution. Easy peasy. Okay, now you're going to try one on your own. Again, calculators are super important in this chapter. So, all right. Hold on, let's go back. Sorry, I should have paused there. Okay, so I want you to realize, pause again. Okay. This one, there's some work involved first, okay? And I thought I put this as a later practice, but that's okay. All right? You actually have to get it down to cosine of x. You cannot solve this until the only thing you have left is cosine x. So I'm going to have to add 1 and then divide by 8, and then I can do my problem. All right? You add 1, divide by 8, and I have cosine of x equals 1/8, and then I can use my chart to solve it. So go ahead and pause the video, do the problem, and we'll look at the solution. Okay, so notice here, so we added 1 divided by 8, and I got cosine of x equals 1/8. I take the inverse of that, and I get 1.445. So my solution is 1.445 1.4455 plus 2k pi and negative 1.4455 plus 2k pi. All right. So these are solutions. Again, it's really simple stuff. And then of course we're going to get into some that's a little more complicated. All right. So what's different about this one is that now we have something that's more than just x in here. Now, if you remember back in the last lesson when we had something that was a little too complicated, we set it equal to u. We're going to do the same thing here. Instead of having cosine of 2x, we're going to have cosine of u. Solve it that way, and then we will go back and plug it back in. So this actually ends up with some really interesting solutions when we have things going on inside of the tree functions. So if you remember that u equals 2x, and cosine of u equals pi over 2, or gives root 2 over 2, okay? And now, so u is going to equal pi over 4, and negative pi over 4, which I actually put as 7 pi over 4. I wasn't thinking about, yeah, that's still, no, I wasn't thinking about the fact that it needs to be between 1 and negative 1. So, anyway, but either one. It has to be between negative pi over 2 and pi over 2. So, you have 2x equals pi over 4 plus 2k pi, because now this is u, right? And u is the same thing as 2x. And then I use 7 pi over 4. I shouldn't have done that. It's still the same thing, basically. Then I have to divide everything by 2. This is a super important step because this is not x equals that, it's 2x equals. So x equals pi over 8 plus k pi, and x equals 7 pi over 8 plus k pi, okay? Or negative pi over 8 plus k pi. Now you have a practice problem. So you're going to do the same thing here. Okay, this is using sine. I think actually the solutions are exactly the same. Okay. So your solutions for this are not the same. It's because the negatives are in different spots. So we have pi over 4 and then pi minus pi over 4, which is 3 pi over 4 plus 2k pi. And it's u equals that, so we have to set 2x equal to it, and we end up with x equals pi over 8 plus k pi, and x equals 3 pi over 8 plus k pi. And those are your solutions. All right, we'll see you tomorrow.